Can you hear now? Is my voice audible? Okay, ma'am. Thank you. Can you see my screen?
Yes, ma'am.
Okay, ma'am. Thank you. Okay, good afternoon, all. So in morning sessions, we have covered file handling concepts, format specifier, command line arguments, and exceptions handlings. Okay. So in afternoon sessions, we are going to say about modules, how we can create a modules, what are the more about modules, packages, and introduction to Python here. So modules is nothing but a file containing Python definitions, functions, statements, and instructions. Okay. So functions will help us to reuse a particular piece of code, but modules goes a step ahead. So it will allow us to reuse one or more functions in a programs, even without function defined in that particular program itself. Okay. So it is a file with a .py extension. It has definitions of all functions and variables and classes. So the program where we want to use these functions or variables, just simply import that particular modules here. So to use this module in a program, what we are going to do, the programmer needs to import the particular module in the program where they return. Okay, for that particular purpose here. So modules, we can say our modules are a pre-written piece of code that are used to perform common tasks. So grouping related code into module makes code easier to understand and use here. So that we are going for a modules here. So any module will be available in any of the three locations here. The first one will be a current working directory. Second will be a directory specified in a Python path environment variable. And third will be a Python installation specific path. Okay. So either three of these location alone, the module will be stored. So if you want to search a module, this module will search firstly in the current working directory. If the current working directory particular module is not available, then the directory specified in Python path environment variable is searched. So if in that particular path also the particular module is not available, it go and search for a Python installation path. Okay, there also if the particular module is not available, it will still we can not found it. Then we can say the import error exception will be generated here. Okay, so either in these three of these locations around models will be stored. So loading and execution. So here modules, if a module is already written, right? So it's written with some functions, variables, all those things using this, they can return up and module. Okay. So those models can be imported in our program, right? So using import statement, okay, we can import the particular module in our program. Okay, must be located and loaded into a memory here. Okay, so they need to be in either of the three directory. Okay, three paths. If and then the particular module should be loaded to the memory before it can be used here. Okay, so to locate and load, it will search for the above three path. So it will search for a current working directory. It will search for a directory specified in Python path environment variable, and then it search for a Python installation specific path. Okay. If in any one of this path, the particular module is available, then in the particular module is loaded into a memory here. So after the particular module is loaded, a compiled version of module with the file extension PYC is generated. Okay, so using this, using this the particular functions available in the program will be executed here. Okay, if the in the same for program, so first we are going to using a module in one time. So say a second time the same model is imported. Okay, so in that time the .pvc file is loaded rather than a .py file. Okay, since it's already compiled version is available, right? So instead of using the same module, the compiled version of module will be used for the second time here. So we have some of the predefined models. There are many predefined models available here. Here I just listed only few one here. Okay, the first one will be sys, second is OS, third is math, and then string, random, date time, calendar. So here only few predefined models are listed here. Okay, so these predefined models are nothing but a system. Okay, so system related all the functions and variables are written in a sys module. OS is already we can see in morning, right? OS is nothing but operating systems related file. It will having a file related functions. Okay, all the file processing functions can be available in a written in a OS module. In morning session, actually, we just imported this OS module and we can work out, right? We rename the particular file, we remove the particular file, right? So for that, those functions are written in the OS module here. Math module is used to import to do all the mathematical calculations, square root, pi, cos, sine. So all the mathematical functions are all the mathematical calculations related functions are written in a math. And then variable values, all the values or log values, every logarithmic, everything is written in a math function, a math module here. String is used to perform all the string related functions are written in a string module here. So alphabets, variables, special characters, those all comes under string, right? So all the things are numbers, digits, everything, hexadecimal values, or everything will be written in a every variable. Okay, string functions, all those written in a string module here. Random module is also course if you want to generate random minute, random number. So those random related functions are written in random module. So if date, time related functions, all the date and fine related functions are written in a date time module. Okay. So calendar related functions are written in a calendar module here. So here I just listed the only few of the modules here. Okay, for your sample, it's a sample one for you. Okay, so here first we actually I just give us a sample program for OS here. So import OS. So here I'm going to get in morning we can see, right, rename and remove function. Here I just giving it get CWD. So CWD is current working directory. So if you are giving this OS module name dot CWD, then it will give a current working directory name. Okay, so here, the accessing variable or functions in modules, how you can access means to use the resources from a module, we need to give a module name dot resource name. Okay, so that's why here we are giving that module name. Here module name will be OS here. Okay, OS dot operator, and then if you want to use either function or a variable, if you want to use a function, we need to give a function name here. Okay, so resources may be a function name or class name, or it may be a variable name here. Okay, whichever available in the particular module here. So here we are import OS module. So here the accession variables in our wave functions in a module will be module dot. We are going to import module dot function name here. Same way here we are using a we are just importing the variable name. So here module name dot variable name is included here. Okay. So the first function will give a current working directory here. The second program in here, I just imported a math module here. So in that, I just declare a variable name num is equal to 16. Here, I just using it two functions. One is a square root sqrt function. In that one, I just pass the number here to the parameter here. So then it will calculate the square root of the particular number and display a number here. I'm just using a format specifier, right? So that the output values will be look good. So I'm using for format specifier f equal to, I'm just passing the variable name within the curly braces. Okay. So that the value calculator will be replaced. Okay. So the value of 16 is, I'm getting the answer here. Okay. So if like that said, next one will be next for value adjust pi value is I just given here. Okay, same way if we are going to use a random, going to import a random module. In random module, I'm just generating a random numbers. Okay, from 1 to 100. I'm going to generate. Here I'm using a list comprehensions. So this we already covered in last sessions, I think. Day before yesterday sessions, they will cover the list concept, right? So here I'm using a list comprehension. So in that list comprehensions, I give a expression here. Here expression will be I just calling a random module dot rand in function. In that I'm just passing some parameters called starting parameter and ending parameters comma 100. So on that I'm using a for loop for as a underscore in range of 5. Okay, so range of 5 I'm going to generate a random number here. So after generating it will be so up to 5 times of 0 to 4 times so 5 times 5 random numbers are generated here, and it will be stored as a list. Okay, random num list. So those random num list is printed in the next statement. Okay, and also same here you using a import date time. Now I just calling a date time module dot now. So now what is the date and time here? So that will be getting, and it will be stored in a now, and then I print that particular date and time here. Okay, so these are the some of the functions we will see a hands-on. Okay, first we will see the sample and then we see the hands-on. Okay, yeah. So the next one will be user defined functions. So here user defined functions, right? So module name, I'm just giving a module name. Here I'm just creating a module. So here for calculator I'm just creating. So I'm just using def add of a comma b return a plus b, and def subtract of a comma b return a minus b, and then def multiply of a comma b a star b return, and divide a comma b if b equal to 0. I just errorizing a error here. Okay, so I'm in morning session we just see the what is exception handling, right? So I just raise an error called can't divide by 0 error. Okay, if it is not equal to 0, then I return a slash b. So that is I divide that particular number and return a value here. So this will be saved in a module called cal.py. So this module I am going to import in my program. Okay, I just importing cal, and then I just assign a value as a is equal to 10 and b is equal to 5 here. Okay, if you are in morning session, we just get use from user. It's like that using input statement, and we also get a input from a user here. So print, I just print the addition. So here I just going to call a call dot add of, I'm passing a and b value here to the arguments. Okay, so then here I'm just giving module name dot function call. So this will call a particular function and the answer will be written here 15. So that will be printed here. Same way here the it will call a module dot subtract function is called here. So it will process a variable and the value will be printed here. Same we are calling this multiple. So module dot multiple function a comma b. So here I'm just passing 10 comma 5, and then this particular function is called, and then it will perform multiplication and return a value as 50 here. Okay, so for division, since it is there may be the exception may be occur, I just giving in a try. Okay, try except block. So to handle exceptions, if they are available, I'm going to handle here. Here I am going to get division call divide a comma b. I just passing so that it will go, and 10 divided by 5 the value will be 2 will be passed here, written here, and printer. In second print statement I just pass as a div dot a comma 0. So second variable I just pass as a 0 here. So try, so it will come here. So in that here I will be checking, so b is equal to 0. So I just going to raise an exception here. So I just raise an exception as here I just giving value error. You can also give as a divide by 0 error. Okay, actually here I need to return as a divide by 0 error. Okay, so in that I just say can't divide 0. Okay, so here I need to 0. So then it will exception will be calling. So here what happened, so the particular actually if there is a value error, it will become here. Okay, so here the except is 0 division error. If it's division, it will getting as into with the value e, and then the value is printed here. Okay, can't divide by 0 is printed here. Okay, so likewise for how for you can create any number of modules. Okay, and then particular module is also imported. If you want to use a user defined predefined models, you can import that module, and you access that module by using a dot operator module name, dot operator function name, or variable name. like that you can access that particular module, or you can create your own module like this, and then you can import it and use it. Okay. So next one is the from import statement. So before that we just import only using a import statement, right? We can also use a from import statement here. So that is first we can import specific attributes we can import. That is only particular variable or particular function alone we can import here. But instead of importing whole module, we can import specifically. Okay, so specific attributes are imported here. So import specific attributes from the module. Use a import file from import function. Okay, so here I'm using from math. I'm going to import a pi. Only pi variable is imported here. So you can use only pi variable from that particular module here. Okay, the usage is the same as it is last. So math.py you can use that. Okay. Next, we can import more than one item from a module here using a from keyword. Okay, here there is using a from math import. We can here I just call importing pi variable, and also I am importing a SQRT square root variable square root function here. So and then I can use both pi variable and square root functions from the math function here. Okay, and then third one, import all identifiers here. Okay, so import all identifier means if same as the import statement. So here import statement import math means it will import all the modules, all the functions, all the variables can be used in that particular program, right? Same way, if we are going to import a math from math import star, it will import all the math modules. So in that program you can also use, it will act as the import module only. Okay, it will in that particular program you can use all the math functions. Okay, and you can perform more calculations. So last one is import item with a different name as use keyword. It's already we can use as, right? So I'm using as keyword. So here from a module import square root as, instead of using sqrt, I'm going to use as a square root in my program here. Okay, so we can rename that particular give a different name or rename to a particular one. So this will not be updated in the module. In your program, you can use it instead of SQRT, you can use the name square root. Okay, but it's not updated in a module here. Module already defined here. The next is a private variables in modules. So in modules also you can normally actually Python by default, all identifiers defined in modules are public here. Okay, but all are accessible by other modules that import it. So wherever the program imported the particular module, all the modules will be all that particular program will have access to that particular module. So that particular module will be public access only. If you want to create only a private variables that will be used only within that module, the programmer should not use that particular variable ones. You can create by using double underscore here. Okay, so private and identifiers whose name should start with a double underscore here. Okay, in Python, identifiers whose name starts with double underscore, that will be a private identifiers. It will be used only within that particular module alone. So the programmer can't able to import that particular variable or use that particular variable from their program. Okay, only variables available public only they can use. Okay, so private and used only models can't be imported in any of the program here. Okay, so this privileges will be available in our module here. See in Python will just executed directly. So without any functions, without anything. So I'm from the scratch. I'm going to write. So morning we are writing program, right? So like that, if we are going to write execute directly the Python files, we will consider as a main module here. Okay. So this main module is a special name called. We can give a special name called and double underscore main and double underscore here. And also it cannot be imported into other modules here. So this main modules cannot be the models which are written in main models cannot be imported to other modules, and also it may import any number of other modules that in turn import other modules also. So this main within the main module you can import many modules. That module in turn may import many other modules here. Okay, but this main module cannot be imported to other modules. Okay, so By default, Python file is considered as the main module here. So actually in morning we can see, right, command line arguments. So in command line arguments, actually we have in command line documents, actually we are passing some modules called sys module, right? So sys module, so without sys module, we are not able to import any, we cannot able to use the command line arguments. So in that we need to import a sys module and we need to get a, we would need to have a avrg variable that will keep track of the command line argument passed there. Okay. So all the argument values are passed in the command prompt. Okay. And execution part is performed from the command prompt and the executed result is also displayed in the command prompt here. Okay, so for that we can use only this model can be used here. Okay, and also to find a name of a model, if you want to find some name of a model, we can use a double underscore name underscore attribute can be used. And also we have some built-in function called DAR. So this DAR function can be used to, if I'm going to pass a module name into a DAR, that will list return list of names defined in that particular module. Okay, so likewise, we have a double underscore built-in model. So that will retains all built-in functions available. Okay. So those are now we can see in a program. Okay. Some advantages of these modules will provide all benefits of modular software design. It will provide a services and functionality that can be used in other programs also. Okay, so wherever need many programs, okay, not only single programs, so many programs wherever needed, you can use that services or functionality available in the particular module, right? More than one programs we can use to here, and also it allows to logically organize code. So it's because if we want to perform all the mathematical calculation, it will be logically organized in a math module. So all the system related work will be logically organized in a this module. So all the file related and operating system related work calculation spots will be logically connected in a OS, right? So likewise, it will allow a logically organized code so that it becomes easier to understand and also use. So if we can say no, right? So if we want to perform some single string operations, so then it's clear for us we only string model is imported and we can use by using that string model we can use all the functions, right? So likewise, we can, since it is logically organized, we can able to understand easier and also use it very easily here. So next is a last of what is standard library modules here. So here it will suppose three types of modules here. One will be written by program. Thus, we can call it as a user-defined model, right? Written by a programmer. So now we are going to write out some program, some module, create a module. So that we can say comes under a written by program. So here, what we can write. See, in our program, we written right some calculator related addition, subtraction program module, user-defined model we written. So that we can comes under a written by programmer. Install from external source means it will be from external source we are going to install some modules. Okay, so that we can for example using pip, we are going to in last how to we are going to see packages, right? So those modules we can be installed from numpy. So those are the packages which can be installed from external sources. So installed from external sources and also predefined pre-installed with python. So pre-installed means already it will, these modules are installed with python that we can sort as the standard library. So those modules will comes under what the which we already see: string, date time, math, random, OS, email, sys. These are all pre-installed with the Python. So in a standard library. So these it will comes under these three types. Okay. So now we can see examples for these models. How to create. Okay. How to use. Okay. Whatever we see, we can do hands on here and then we will move on to our packages. I'm just opening Python. Wait a minute to open the Python program. So first we can use some user defined modules. Okay, I just import sys module here. So and then I'm going to print. I'm going to print the Python path here. So for that I need to what I need to I have to access that particular module. I need to give a module name sys dot. I'm need to call a variable path here. So in that one it will call and get the value. Okay. Now I'm going to save that particular file here. Just trying to save as a path itself. Okay. And then I'm going to run that particular one. So it will give okay. So in that user minimum PC update local Python 3.c. So what is the path of the path I'm going to use? So that will be displayed here. Okay. So for this only this path will be available here. So if I'm going to import import math here. Okay. So we can also use using command line. Actually, we morning it's not working right now. We can see import as sys a is equal to int of. We are going to get sys dot argv of 1. So it will get the first value variable first value from the command line, and I'm going to get the second value in this module dot variable argv of 2. And then I'm going to sum add here. I'm going to add a function, sorry, add is equal to a plus b. Okay, and then I'm going to print print sum colon. I'm going to print pass the variable. All right, I just saved as path.py, right? So what I need to, I'm going to run it in a command prompt. So command prompt cmd here. There I need to give a function name, sorry, module name, right? File name p path dot py, and then I'm going to pass a value 10 and then pass a second value 12. Just rename it. Okay, save as. sum. So sys dot argv of 1, sys dot arg of 2, and then I am going to add, right? So everything I just given correct. Okay. So here I am need to give a sum dot py and then giving value. What happened? Now also it's not working. So I just try to get straightly. Okay. In sum dot py. It's coming some star. You will see just value printed here. Okay. I'm just to try to print AR GV of 0. Will pass and try. Sorry. We need to run in command prompt, right? Now I'm good to go. Sum dot py. Sorry, some problem in this RGB. Oh, I didn't go sys dot, right? Yeah. Sys dot save. Sorry. Sum dot py. Here the path is printed, right? So it's going, it will get the argv of 0 value, and then the values printed here sum. So then we will check argv comma sys dot argv of 1 comma sys dot argv of 2. We are going to get two input values. Okay. Save, and then we are going to run. Sorry. We need to run in command prompt, right? I'm going to run here sum dot py, and then I'm giving 3 and then giving 4 value. Okay, so it's printed. So it will give the path that sum right way, and the second variable 3 and second variable 4 is printed. If I'm going to save it in some variable here. So a is equal to sys dot ar gv of 1. I'm going to save, and then I'm going to save b is equal to sys dot argv of 2, and then I'm going to print the values, print a comma b. Save. Sorry, actually did. And go to a command prompt, and now we need to give a function file name sum dot py. I need to pass a parameter, right? Two parameters. I'm going to pass a parameter 10 and then 15 here. So here we are getting, right. So I'm just getting a sum dot py. First I'm just giving a print statement as I need to pass a list value of 0. It will give a file name, and then 1, 2 will be the input arguments here, command 10 arguments. So in first one, I just getting the file path here. using some by. Second input I'm just going 10 and 15. So that is stored in some variable A, and second is stored in some variable B, and then I'm printing that variable two variables A and B. Here I to get 10 and 15 is printed here. So now we could try to calculate here. Say is equal to A plus B, and then I'm going to print C here. Okay, say sorry, we need to go to command prompt. In that command prompt we need to go sum dot py, and I need to pass 10 and need to pass 15. Since here the arguments passed here, why it's has 10 and 15? The argument passed here is as a string arguments. So this plus operator will act as a concatenation here. So that's why we try to convert that into a integer part in last one, right? Now we will try to convert now int of b. So we are going to convert the string as into int, and then second b value also to int. And then save. Now we just try to print. Go to command prompt. Now we are going to go sum dot py, going to give value 14, 13. Now the value is added, right? 14 plus 13 is value is added as 27, and the print here. So like this the command prompt will be working. Okay, I think now it's clear, right? Morning it's some issues, so unable to print. Now I think all are clear about this. So these are all for these functions we are using a sys module here. Okay, next module we will see about a math module here. I'm going to import math here. Okay, and then we do to we can use pi and square. We can perform some operations. Okay, so I just print. Okay, I'm just printing pi value on math dot pi. Okay, so we will save, and then we will run that function. So here math.py value is 3.14. The whole value is printed here. Okay. So next, if you are going to find a square root, I'm going to print find sq or t, right? Square root bracket. I'm going to go 16 here, and then close the bracket, save and run. Sorry, actually we didn't give module name, right? Module name dot function call. If you miss that one, you will get face an error. Okay, so the square root will be printed here. So I'm importing a math module. I'm just printing a pi value and square root value here. Okay, so if you are using a from keyword, so how to do? We are going to from math. Okay, I'm going to import pi. So now I'm going to try both also. Okay, then only you can know. So here I have got an error. What is the error? I have a math dot. The name math is not input, right? So I'm just delete. So okay, whole math module is not imported here. So here what happens? So if you are using from module, there is no need to give a module name dot. Since we are just importing only the particular variable or function, right? So we can straightly use that particular variable or function here without using a accessing using a module name here. So first one I just what I just give a pi. Okay, for starting I just give as a math.py. Since I'm not importing the whole one, just importing only pi, I can they directly use a pi, right? Okay, so I'm just giving pi, and also I'm just giving a square root, but I'm importing only the pi value here. I'm didn't import the square root function here. So the pi value is printed, but the square root value is not imported here, so it will give a name error here. If I am going to import that one, sqrt, so then the square root values. So from keyword is used to use a specific, used to import only specific part of attributes. Okay. So and also I already said it. If you can use also, you can give it a name here. Okay. Import as square root as yes. Okay, we can simply give yes. Yeah, just comment it here and give yes. What happened we can see. Okay. So value will be printed. So I'm giving a different name for a sqrt using a as keyword here and using the different name in all my program here. Okay. So this is out from keyword. So we can see from math, we import a specific one. We can also see star. Okay. How it works. sqrt. Okay. So if you are going to give star means okay. Here also if you are going star means no need to give a model name. If you are using from no need to use a model name. If you are going to use statement to import, you need to give a model name dot function name or variable name here. Okay. So here star I just do it. So there are all the functions and variables are imported here. So in from that module, so I'm just using a giving a pi value and square root value. Okay. So these are all about from input statement. I think we see all the from input statement, right? And pass command line arguments using sys modules is already okay. I just said right. We can get the find the name of a model using name attribute. We can see that one. Just I'm going to. So here, this is not a it comes from our code. Okay, it's a normal one. Print. I'm just giving welcome to module in Python. Okay, and then I'm going to print module name. Module name. Okay, comma. So which operator we need to use? We need to give a double underscore name. Okay, double underscore close. Okay, and I'm just saving here. I'm going to run that module here. So welcome to model Python. The model name is main here. Okay. So if we are defaultly whatever program we are return. Okay. So those all considered as a main module here. Okay. So that will be written here. So next we can say we can DIR. Okay. DIR we can go module name, math module name we can go. Okay. Module name and we can we need to print and then only you can know, right? Print, save, and ODAR dot model name. What are it's given? Not defined. So we can import that one. Okay. Import math and then we run. Okay, so look at a model. I just give you model name as what the model main. So in that math model, what are the packages? What are the things available for? We have a document, loader, name function to get name, package, specific, see a cos sketch, a sine, tan, all the cosine, sine, tan related functions, then distance, okay, expression, see factorial, fabs, floor. So using factorial, we can see, okay, whether it's working or not. They're giving some factorial right available. So we can give print math dot factorial. So factorial, right? Math dot factorial of 4 we will go. Okay. Um, we can just give a hash for that. No need to print all this one. Okay. Oh, I missed to close bracket. Close this one. Save. I'm going to run. Print. Oh, print. I just giving a number. Print mistake. Okay. Now we will run. Welcome. Factorial is fine, right? See, it's right. Easy to instead of coding all this one, we can have a factorial function like that. But we can try it on square root already. We can see, right? So we can see is check for sine series. Sine 30 we can send and then run. So the value of sine 30 will be given here. Okay. Power. We can use power value. Okay. Power of 4. Then run. Oh, power value we need to give 2 value, right? 4. Save. Print. Oh, sorry, instead of comma, I just given as a dot. Save. Okay, so 4 power 4 is printed here. So like this, all the math models will be used. Okay. Next, we can use a we can create a user defined OS. Okay, OS we didn't try, right? We'll try some OS function. OS just to print CWD itself. Okay, print OS dot get current working directory. Save and then print file. So the current working directory is the path there. Okay, so like that OS model is also used here. If you want to use a calendar here, okay. Here we used right calendar we used here. Okay, let's see. Sign just to print calendar dot month 2025 comma 1. First we need to give a year. Okay, save, then calendar, calendar, calendar dot month. You can go DAR. Okay, DAR calendar. See, what must I think spelling mistake. Sorry, CALENDAR, right? So the January 2024 calendar will be printed here. Okay, and this actually I didn't give it in print statement, so it's not showing here. Okay. Okay, so like this, the month we can give calendar, December. Okay, so these are all the functions which will be already written in the functions and variables which will be already written in the calendar module. Okay, leap year, leap year functions, date, time, everything will comes under a calendar here. Okay, and random we can see one. Okay, so random, RANDOM, random for I in range. I'm giving 10 here. Okay, range of 10 colon. I'm going to value is equal to v is equal to random dot rand int dot 1.100. Okay, and then I'm need to print b, save, and then run. Sorry, I didn't give bracket, right? Save. Okay, so up 10 from 0 to 100, 10 random will be generated using a random minute. Okay, and it is displayed here. So 10, 80, 90, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 random numbers generated here. Okay, so these are the predefined functions which we are available in a module here. So you can also create a user defined modules here. So I'm going to use a creating a sum, right? Def value a comma b comma c colon return a plus b plus c. Okay, save. So this is a module which I'm going to create is a sum.py module. Okay, I'm going to use that module value in my own. So here I'm just going to get the value. Okay, value 1 is equal to int input of enter first value, and then I'm going to just copy paste here. Okay, for value 2 and value 3. So I'm just to change it as value 2, and then I'm going to change it as value 3. Enter a second value, enter a third value. Okay, before that I need to import, right? Import sum. Once again. Mm. Okay, so we are going to get the three values here, and then I'm going to print. I'm going to call a addition module here. So print sum, comma. I'm going to call it sum dot the model name that I created as add. Sorry, sum. Sorry, I didn't create a model name, right? Function name it will give. Sorry, sum dot add. I'm going to pass these values v1 comma v2 comma v3. Okay, so save it in the same place. Okay, so I'm going to sample one s1 s2. Okay, I'm going to save it as a s2 here, and then I'm going to run here. Actually it's cutting here. We will run, close and run. Okay, run. I'm going to pass the first value is 12 and second value is 32, third value is 45. Okay, so it's called that particular module, and then I'm getting the answer here. So I'm just importing my user defined module here sum. Okay, and then I'm going to call a function add function. Okay, and then this will be performed. Calculation part is performed and the value is written here and it is printed here. Okay, so like this we can create a user defined modules here. I think you all clear about modules, right? We can move on to a packages. So we move on to packages, right? So the packages is nothing but a collection of Python models. So these Python models will containing an additional set. So Python, if we have like I created some module, right? Like we can create a many modules. All these modules have comes under one package. Okay, so we can that we can call it as a packages here. So it's a hierarchy file. It's a we can say it is a hierarchical file directory structures that has a modules and other packages within it. So one package may contain many modules and also other packages also it may contain within it. Like modules and packages, you can also create it easily. By like models, we can also create packages easily in Python here. So every package in Python, since it's work as a folder here. If we have some folder, okay, I have a Python folder. In that, I'm going to save all the Python files. Those Python files will act as a module, and the particular folder will act as a package here. So differentiate the directory, that folder, to the package. We are going to include one more file called a init file. Okay, that is init.py. So this is a file we can additionally include it in the package here. Underscore underscore double underscore init double underscore dot py file. So this will differentiate the package from a directory here. Okay, so it is used to initialize a Python package. Okay, so this will contain all the input statements from of the all the models. What are the models will be available in the particular package? All those import statements will be given inside the init.py. Okay, so it is simply this file may not have a single line of code. Okay, only just it we are giving a import that particular module alone. So it is simply added to indicate that this directory is not an ordinary directory. It contains a Python packages. Okay, so this may be empty file used to execute installation code for all packages here. See, this in program packages can be imported as same as a module. Okay, how we are imported module here? The same way we can also import a packages also. Okay, so we can see. So here I just included the steps how to create here. So first I created a some package. Okay, sample name sample here. The sample package I just created inside that folder. I just add a module and sub module. So and then I just created a init file .pfl. In that init file I'm just giving from. I'm going to give add. In that I'm going to use only one function called sum. Okay, this is the add function. So inside I'm just giving coding layout. That's all. Okay, sum function. So that will be imported here. Same way from dot sub import I'm just having one function called diff imported here. Okay, and then I save it file. Okay, so then it will be a creating a new package file. Okay, and then what I'm going to do is I'm going to import a sample package with dot. I'm going to import the add module here. Okay, so from the package I'm going to import the add module. So sample dot add here. So and then print. I'm just giving sample dot add. In that I'm going to call a function sum. So dot sum. So here I'm going to pass a values 2 comma 3. So then it will run and then we'll add that value and I can get a value as a 5 here. Okay. So Python package index. So this is something with py. We can simply we can say it as a pypi. Okay. So before that, actually, we can use two ways to import here. Same way in the modules. Okay. So we can import a package name dot module name, or we can import from package name import module name. So that also we can possible. Okay. So there in modules we can use from keyword, right? From module name. Import package import function name or variable name imported, right? Same way here we can import from package name import big module name. So this also we can able to include here. Okay, so next is a python package index. Python package index, shortly we can say it is a pi. So here it's the third party. This is a many third in python, many third party models are stored in python package index here. So to install them we are using a pip. Okay, pip command. So new version of Python have these modules installed by default here. Once you have these modules, installing libraries from pip, installing libraries from Python package index become very easy here. So for that, what we are going to go to the command prompt, go to command prompt. Okay, we need to enter a pip install library name here. Once library is installed, import in program and use it in a code here. Okay. So before that, so using pip, we are going to install a pygame here. So for that, first I need to have open a command prompt. Okay, so it's open command. Here I'm going to install pip. Okay, install pygame here. Pygame is a library, right? So library name. So I'm going to install pygame. Since it's a third party in a module, I need to install before it's used. Okay. Since actually already already itself I just installed that pgame. Okay, so that it will comes under requirement already satisfied. If I'm not installing already, then it will download and install all those pygames and then it will give a successfully installed pygame will be message will be given here. Okay, so once that's done you can go to a pygame module. So this is the command where we can use a this is a Python package index. Okay, so using pip we can install all the third-party models. So pygame, numpy, pandas, matplotlib, scipy. So those are some of the models which is the third-party models we need to install using a pip command. Okay, so the last part of your program session will be introduction to pygame here. So this Pygame will be open source library. It's designed for mainly for video games. That is, there is an open source library designed for writing video games in Python here. So it simplifies the process of creating games and multimedia applications. It provides tools to handle graphical output, sound, and user inputs here. So it is a Pygame is built on a top of the SDL. SDL is nothing but SDL library. SDL is nothing but simple direct media layer. Okay, so in that only the Pygame is installed built in here. So it will provide a low level access to graphics, audio, and input devices. So it is used to draw shapes, lines, images on screen, create animations, play sounds effects, and grab background musics. So many things we can done using a Python. So you can create your own games using a Pygame. So it will, makes easier to create games easier here. In using Python, it's very easier here. Okay. So the steps mainly followed here is the initialize Python game. So to initialize Pygame, we need to set up internal modules for graphics, sounds. This initialize Pygame will set up internal modules for graphics, sound, and input handling. Okay, and then second step will be we need to create a window here. So for in that window only the particular game will be to be run, right? So for that we need to set up a window or screen where game will be displayed here, and then we need to create a game loop. How that particular game will be work here. Okay, so here continually update screens process input and handles game logic here. Okay, so at last we are going to quit the game. Okay, quit game. So when game over, properly exit the by game to free up the resources here. Okay, so some of the important functions we are used here in pygame is pygame.init, pygame.displaySet underscore mod, pygame.event.get, pygame.display.flip. So pygame.init will initialize all the pygame modules here. So display.set mode will create a window of a specified size, and then pygame.draw circle. You can also have a draw circle will draw the border, draw the shapes on the screen. Event dot get will checks whether the event like pressing closing entering key, so like that any event is processing or not, so that will get the event get. So display flip is nothing but updates the entire screen. It will update the entire screen here. Okay, we can see one program running with this one. Okay, I just open. Already I have saved that one. I will open it and show you. I'm just take a program for bounce here. Okay, so here I'm going to import a sys. So sys is a system models we need to use here, and the pygame packages like so in that pygame model need to be imported here. So this will sys will provide a functions to interact with systems like exiting the program. Okay, if we want to exiting from the program, we need to use a sys. Okay, this pygame library for making games in Python, we are using a pygame module, and then second line we are using a pygame.init. As already I said, this is the all pygame modules such as graphics, sounds, etc. Those modules are initialized here. Next will be a size of a window here. Size equal to width and height we are going to go. Since I giving 700 and 250, the width is taken as a to 700 and pixels, and 250 pixels height will be taken. Okay, and then I'm just giving the speed as a 1,4, 1,1. So background, I am setting that window background will be a 255, 255, 255. That means the white background. Okay. So RGB specification only. So I want a white background. So I'm just setting as a background as 255, 255, 255 here. Okay. And then I'm just going to give a screen is equal to, I just set at this is one of the important function. So display dot set mode. Here we are going to give a size. Okay, so size already we can say that width and the height of the red, so that will be passed here. Okay, so this will create a gray window with the given we have width and height here. Next, pygame dot display set caption. Within that I'm just giving a bouncing ball, right? So this in the window it will give a name of that window. Okay, bouncing ball window. Okay, so set the window title to the as bouncing ball here, and then I'm just using ball is equal to pygame.image.load. Here I'm just already keeping some ball images here. Okay, but already I just saved some ball images here. So that image is used here. Okay, here I just saved your ball images as JPEG here. Okay, so and that and that but that will be passed. That image is passed here, and it will be saved as a ball here. Okay. So this will load a ball image here. Next, ball rect equal to ball dot get rect. So this will gets a rectangle bounding box for image, which is used to easily manage position and movement of the image here. Okay. So after that, I'm going to give a while one. One second. Wait a minute. So then while one means it's always true. So it will enter into a loop. So here I'm just giving a time delay. Say 2 means it's a milliseconds. It's a give a milliseconds delay only here. Okay. Loop running in, is a this will loop running infinitely. So for that, first we are going to give a event in Pygame get event. So in that event type is quit. That is, we are going to close that particular file. We are going to call a sys.exit so that the program it will exit the program. Otherwise, it will indefinitely run that loop. Okay. Then I'm just to pass a ball record ball here. I'm just in move, I just passing the speed. Speed is already given us x-axis and y direction. I just give. So every iteration of game will loop. It will shift out by 1 pixels to right and 1 pixels down here. Okay. So like that, it will be move on here. And then I'm going to check a game loop here. So ball rect dot left is less than 0 and ball rect dot right is greater than 0. I need to minus the speed. So same way ball rect top is it. Here I need to change the directions here. So here I need to check for collision with window edges. If the collision is detected, the direction of movement is reversed, making ball bounce here. Okay, so checks if a ball hits the edges, okay, of the window, left, top, right, and bottom. So those conditions will be checked, and based on that, it will be reversed here. Okay. So then finally, I'm going to screen fill with background. Background already giving us 255, 255, 255. So the background is filled with a white color here. Okay. So and then lastly, blit. So this will use it to draw a ball image onto a screen at the position specified by the prompt. So what is the position we just specified here? So and that in that particular position, the ball image is drawn in that particular screen here. So this display flip will updates the entire display surface to show the changes made in game loop. That is ball movement will be shown here. Okay. So we just run and see whether it's how it's working here. So like that the game will be. So the bounces, okay, it will go up and down, up and down, up and down. Once it hits the edge, it may to reverse. Okay, reversely come. It will hit the edge, it will comes down. It hits the particular edge, it will comes to right, it will comes to reverse, and if you click it's left, it will comes to right here. So by jumping, it's bouncing. Okay. Okay, that's all about Pygame here. I think you are so like this, you can here I just bouncing ball is used. So like that, you can create any game. Okay, so with using predefined functions, I can create any game using a Pygame module. So up to this, we can see what is package, what is modules. We can see predefined models, user models, how the models can be created, and how the models can be imported and used in your programs. And also we can see what is the packages, what and then we can comes under was libraries. Okay, so we can see a introduction to Pygame. It's in that Pygame we can see some of the functions, important functions which are used in a Pygame, and a small program related to the Pygame. Okay. Okay, that's all about this. Thank you all. If you have any questions, you can ask.
Participants, if you have any doubt, you can ask, and you can also use chat window. If you are have no doubts, shall we wind up the session? Ma'am,
Yes, ma'am.
shall we wind up the session?
Yeah, sure, ma'am. Actually, thank you. Actually, thank you for participants. I think these sessions will be useful for you. If you have any doubts related to this in future also, you can message me using my mail ID. Okay, sukanyaJS@gmail.com. So if you have any doubts, if you want any clarifications, you can message me. Thank you, ma'am. You can wind up.
Yeah, thank you, ma'am. I would like to thank you for today's speakers and coordinating the session with some. And I would like to thank all the participants. And all the participants are asked to seriously feedback for their code that I have given in the chat window. Thank you all.
Thank you all.